Simpson's rule. Simpson rule. Simpson's rule is a numerical method for approximating the definite integral of a function. It is named after Thomas Simpson, who published it in 1743. It is used for finding the areas and volumes of irregular figures. The rules are based on the idea that the edges of these figures are curves that adhere to a precise mathematical formula. They provide a good approximation of areas and volumes when used with ships. In understanding Simpson's rule, we must first learn what is a waterplane area. WPA. The waterplane area, often referred to as the waterplane or waterline plane, is a significant concept in naval architecture and ship design. It relates to the area of a ship's hull that is in contact with the water surface when the ship is afloat. This area can be visualized as the cross-sectional area of the ship's hull when viewed from the side at a specific waterline or draft. If you cut the ship at the waterline, that plane will be the waterplane area. WPA. This is the waterplane area. The WPA has equidistant frames, except at the forward part, where the distance between the frames are nearer to each other. We can obtain the distance of each frames from the ship's plans. For calculation of area using the Simpson's rule, we will use the half of the WPA. Note, if you can calculate the area of this half WPA, then you can multiply it by 2 to obtain the area of the waterplane, WPA. The half WPA is an irregular shape, and we will use the Simpson's rule to calculate the area under the curve. The Cartesian system of coordinates. From the figure here derived from the half WPA, we can use the Cartesian system of coordinates with x-axis, abscissa, and y-axis. Ordinate. The x-axes are the intervals and normally have the same distance. The y-axis are the ordinates, and it is connected to the curve in the half WPA. The Cartesian system of coordinates. Y-axis is shown vertically at the left side, with values from 0, 1, 2, 3, 4, 5, and 6. X-axis is shown below the figure with values 0, 2, 4, and 6. Simpson's first rule. Description of Simpson's first rule. A. This rule uses the Simpson's multiplier 141, 14241, 142441, and so on. B. This rule needs at least 3 ordinates. C. This is used when the number of interval in the half WPA or waterplane area is divisible by 2. The figure shows 3 ordinates and 2 intervals. You can use the Simpson's first rule. This figure has 3 intervals and not divisible by 2, so you cannot use the first rule. The figure has 4 intervals and 5 ordinates. You can use the first rule. The figure has 6 intervals and 7 ordinates. You can also use the first rule. The figure has 5 intervals, and it is not divisible by 2. You cannot use the first rule. Simplified formula of Simpson's first rule. Area equals 1/3 multiplied by height and multiplied by the product of Simpson's multipliers and y-axis. That is for 2 intervals. Area equals height divided by 3 multiplied by the sum of y, 1 plus 4 times e2 plus i3. For 4 intervals, area equals height divided by 3 multiplied by the sum of y, 1 plus 4 times ei, 2 plus 2 times ea3 plus 4 times i4 plus e5. You can also arrange the formula as area equals height multiplied by the sum of y, 1 plus 4 times ii, 2 plus 2 times y, 3 plus 4 times i4 plus i5, and the product is divided by 3. Example: find the area of the figure below using Simpson's first rule. Let us write the given. y1 equals 2, i2 equals 3.9, i3 equals 5.2, i4 equals 6.1, i5 equals 6.7, i6 equals 6.6, and I7 equals 6.2. The common interval x is equal to h, height, and equals 2. Solution: area equals height over 3 multiplied by the sum of E1 plus 4 times E2 plus 2 times E3 plus 4 times E4 plus 2 times E5 plus 4 times I6 plus I7. Area equals 2/3 times the sum of 2 plus 4 times 3.9 plus 2 times 5.2 plus 4 times 6.1 plus 2 times 6.7 plus 4 times 6.6 plus 6.2. Area equals 2/3 times the sum of 2 plus 15.6 plus 10.4 plus 24.4 plus 13.4 plus 26.4 plus 6.2. Area equals 2 over 3 times 98.4. Then rearranged it as area equals 2 times 98.4 and then divide it by 3. Area equals 196.8 divided by 3, and area will be 65.6 square units. The easiest way to solve this by Simpson's first rule is by tabular form shown below. Ordinates times multipliers, then the sum of the products is divided by 3, and the quotient is multiplied by 2. The result is 65.6 square units. As easy as that. Simpson's second rule. Description of Simpson's second rule. A. This rule uses the Simpson's multiplier 1331 B. This rule needs at least 4 ordinates. C. This is used when the number of interval in the figure is divisible by 3. The figure shows 4 ordinates and 3 intervals. You can use the Simpson's second rule. Simplified formula of Simpson's second rule. Area equals 3/8 times height times the product of Simpson's multipliers times I-axis. That is for 3 intervals. Area equals 3/8 times height times the sum of I1 plus 3 times E2 plus 3 times E3 plus I4. For more than 3 intervals, for example, 6, 9, 12, 15, and so on, the multiplier will be shown next. For more than 3 intervals, for example, 6, 9, 12, 15, and so on, the multiplier will be as follows. One, 3, 3, 2, 3, 3, 1 for 6 intervals, and 1, 3, 3, 2, 3, 3, 2, 3, 3, 1 for 9 intervals, and so on. are the multipliers for Simpson's second rule? Example: find the area using Simpson's second rule. Given y1 equals 2.2, I2 equals 4.3, y3 equals 5.2, y4 equals 5.8, and height equals 2. Solution: area equals 3/8 times height times the sum of y1 plus 3 times e2 plus 3 times ei3 plus i4. Area equals 3/8 times 2 times 2.2 plus 3 times 4.3 plus 3 times 5.2 plus 5.8. Area equals 3/8 times 2 times the sum of 2.2 plus 12.9 plus 15.6 plus 5.8. Equals 3/8 times 2 times 36.5. Area equals 3/8 times 73. Rearranged now as area equals 3 times 73 divided by 8. That is, area equals 219 divided by 8. Area will be 27.375 square units. Another way to solve is by tabular form. Ordinates times multipliers, the products are totaled, then multiply it by height, which is 2, then multiply it by 2 and divide it by 3. The result will be 27.375 square units. Simpson's third rule. Description of Simpson's third rule. A. This rule is used when the area between two adjacent ordinates are required. B. This rule uses the Simpson's multipliers 5, 8, and -1. C. This area can be calculated when there are 3 adjacent ordinates, so that you can apply the 3 multipliers 5, 8, and -1. Formula for the third rule. Area equals height over 12 times the product of Simpson's multipliers times y-axis. Refer to the figure Area 1, which is the shape ABCD, and Area 2, which is the shape CDF. The formulae for Area 1 and Area 2 are as follows. Area 1 equals height over 12 times the sum of 5 times 1 plus 8 times I2 plus -1 times E3. And Area 2 equals height over 12 multiplied by the sum of 5 times I3 plus 8 times E2 plus -1 times I1. Example: calculate the total area of the figure below using the Simpson's third rule. Given height equals 2, we1, point A, equals 7, E2, point D, equals 7.6, and y3, point E, equals 7.3. Required: Area 1 at ABCD and Area 2 at DCF. Solution: for Area 1, ABCD, Area 1 equals height over 12 times the algebraic sum of 5 times E1 plus 8 times E2 plus negative 1 time E3. Area 1 equals 2/12 times the sum of 5 times 7 plus 8 times 7.6 plus negative 7.3. Area 1 equals 1/6 times the sum of 35 plus 60.8 plus negative 7.3. Area 1 equals 1/6 times 88.5. Rearranging them 1x 88.5 and divided by 6. The result will be 14.75 square units. Solution: for Area 2, CDF. Area 2 equals height over 12 times the algebraic sum of 5 times EI3 plus 8 times E2 plus negative 1 time I1. Area 2 equals 2/12 times the sum of 5 times 7.3 plus 8 times 7.6 plus negative 7. Area 2 equals 1/6 times the sum of 36.5 plus 60.8 plus negative 7. Area 1 equals 1/6 times 90.3. Rearranging them 1x 90.3 and divided by 6. The result will be 15.05 square units. The total area equals Area 1 plus Area 2. Total area equals 14.75 plus 15.05. The total area will be 29.80 square units. Another way to solve is by tabular form. Ordinate times multipliers for both tables ABCD and CDEF. Then sum of the products will be multiplied by the height, which is 2, then divided by 12. Result in Area A1 is 14.75 square units, ABCD, and result in Area 2 will be 15.05 square units, CDF. The total area is the sum of Area 1 and 2. Total area will be 29.8 square units. Additional info. For the tabular method for Simpson's first, second, and third rules can be made using Excel, and you can program the cells so that the table will give the result automatically. Practice the Simpsons' first, second, and third rules. So that you will obtain high scores in your exam. Enjoy learning. See ya!